It's the K-12 Engineering Education Podcast for February 20th, 2017. I'm your host, Pius. My two guests today are both from the University of Delaware. They are mechanical engineering professor Dr. Jenni Buckley and teacher professional development expert Dr. Amy Trauth-Nare. They created a hands-on curriculum for 6th to 12th graders in orthopedics engineering. That's the field that involves sports medicine, joint surgery, bone saws and drills, and all sorts of stuff like that. I spoke to them about this project and more over Skype. So I would like to welcome to the show Dr. Jenni Buckley and Dr. Amy Trauth-Nare. Welcome.
Thanks. Glad to be here.
Could you just introduce yourselves real quick, what you do at the University of Delaware? Maybe we'll start with Jenni.
Sure. My name is Jenni Buckley, and I am a mechanical engineering professor here at University of Delaware. I teach a range of classes. A lot of them are in design. Some are theory-based classes. And my research expertise historically has been in medical device design.
And Amy?
Yeah, my name's Amy Trauth-Nare. I am the Senior Associate Director for Science Education at the Professional Development Center for Educators. It's a center that provides outreach and professional support to practicing teachers in K through 12.
Since a lot of the listeners are K-12 teachers, what do you do that's specifically related to K-12 STEM teachers?
So Jenni and I collaborate a lot on professional learning opportunities for K through 12 teachers in the arena of engineering. I also I'm out in the K through 12 schools in the state of Delaware and sort of regionally. And I do a lot of things in the classroom. Like some days I go in and I get the honor of co-teaching with a teacher. Other days, I might be sitting with a group of students and helping them along. A lot of times what I do is I'll sit down with the teacher during planning period and we'll talk about instruction that he or she is planning and help sort of resolve problems of practice. Sometimes teachers just have like conundrums or quandaries that they're trying to solve in their practice, and I end up being that sounding board for teachers to help them come up with solutions to the challenges that they face in the classroom.
In addition to PD, Amy and I are really involved in new curriculum development. Particularly in the area of engineering. We've created some curriculum ourselves that we'll talk about called Orthopaedics in Action, but we also run PD sessions for teachers where we show them how you can create your own design exercises that are contextual and aligned with the standards. So my role with Amy is really as kind of a content expert. She knows the teachers and kind of the constraints that they're facing in the classroom, and she'll kind of look to me for ideas about how to bring in engineering and where that fits within some of those standards.
And so, Jenni, do you focus mostly on mechanical and biomedical stuff or orthopedic stuff, or is it really just all over engineering?
It's all over. I would say my specialty is probably objects that are solid. So as a mechanical engineer, you kind of do a little bit of everything. So you have things that are solid and things that are fluid and things that heat up and cool down.
I'm familiar, yeah.
Specialty, yeah. So I'm more of the solid objects, which it really maps nicely to what's happening in the K-12 space in physical science classrooms and then also in physics classrooms.
And Amy, you were saying something interesting that in addition to being a professor, it sounds like you're really in the trenches.
Yeah. It's really a great job because I was a middle and high school science teacher before I ended up going to graduate school. And I loved it. And one of the reasons I went to graduate school was I wanted to know more. Like I wanted to be able to help other teachers do the best job that they could do. Because the reality is most teachers go to work every day because they love teaching kids and they really want to pass on their love of STEM to kids. So that's why this job is so great, is I get to be in classrooms with teachers several days a week and to help them sort of enact that vision.
So Jenni had mentioned Orthopaedics in Action, the curriculum that you both helped create. It sounds like your experience in the classroom really helped inform that curriculum. I was wondering if you guys could talk about it more and how it got developed and what it's all about.
Orthopaedics in Action is how the two of us actually met. So, it's our origin story. So I co-founded an organization called the Perry Initiative with a surgeon friend of mine. So I spent my early years in an academic medical center doing medical device design and testing for surgeons. So I was in a research lab and co-founded this organization with a surgeon friend where we're trying to get women interested in careers in engineering and in the areas of medicine like orthopedic surgery where you don't find a lot of women. So the Perry Initiative we started in 2009, and it is a great out of school time program for high school girls. We have about 40 sites all across the country, and what we figured out in the midst of building out this kind of nationwide outreach effort was that the two of us were actually really good at curriculum design. We made stuff that was, as I call, kind of sticky. Like kids really were engaged in it. So we were bringing in these high school girls and getting them to do hands-on kind of activities, and they really liked it. So Orthopaedics in Action was us trying to create a version of this Perry outreach program, which is 400 pounds of equipment that we ship all around the country to various medical centers. Can we make that teacher friendly? And can we also make it standards aligned? And I didn't know the first thing about that. So I had no sense really as a person with a research background teaching in a college classroom what was possible in sort of the K-12 space. So fortunately I met Amy, and she was able to kind of guide the process of development of Orthopaedics in Action. So it's 7 now standalone classroom exercises that teach engineering concepts. So concepts like stress and strain and pulleys, but through the lens of orthopedics and the musculoskeletal system. So I like to think of it as a sneaky way of getting people who might be interested in biology, particularly girls, interested in engineering, because you kind of sneak the engineering in there with the biology. That's been a really great partnership, and that's part of the Perry Initiative. The Orthopaedics in Action is our in-classroom curriculum, and we were fortunate enough to have, sort of both of us wearing our UD hats, University of Delaware hats, developing it.
Yeah, how long ago did you start that?
Yeah, so Perry Initiative, we've been around since 2009, and at this point it winds up being about 1,700 high school girls per year and another 500 medical students during our day-long programs. And we have about 40 sites, so we're at all the Mayo clinics and some of the Shriners hospitals and places like that. And our goal is to be in enough places where people can attend one of our weekend programs. Orthopaedics in Action, we started in 2014. Yep. That's when we started developing it. And we had a team of students here at the University of Delaware, engineering students who were seniors who helped us build it out as part of their senior design project. And then we went commercial. We have a commercial partnership with a group called Sawbones. They are a really great manufacturer of medical models, particularly bone models. So they're our manufacturer and distributor, and they were really great about helping with some of the development costs and keeping the pricing really reasonable for teachers so that we can get a lot of this out in the world. So now we've got close to 200 of these classroom kits out in schools, and we keep seeing more and more people adopt it every day. So it's been really amazing. And they're people we don't know. That's the most exciting part. I tell my students, you've really made it when people you don't know buy your products. That's the goal.
I think you really got something there, because personally, I used to work in the orthopedics industry, and I would have loved to have a kit like that. I looked a little bit at some of the stuff you have online. And what's the website again if teachers want to look up stuff about that?
Yeah, so you could just Google Orthopaedics in Action, and it's going to come up under, you can purchase it on Sawbones, okay. Sawbones, sawbones.com. Or you could go to our website at the Perry Initiative, which is perryinitiative.org, and you'll see a link there to get the curriculum. You can preview it for free, so you can get all of the lesson plans and the video PD. So Amy was very particular that we have very clear video PD, so you can see some awkward videos of me and Amy. But that's all free for you guys, for folks to look at. And then we just had an article come out a couple months ago in the Science Teacher
and it published by the NSTA. So we published one of the lessons on center of mass in the science teacher.
So you can go. It's a way to make a balance board. So basically, measuring center of mass on your own body or your students' bodies. Just a very simple balance board. $40 at Home Depot, and you've got the whole setup. So you can also check that out as a way to preview. But definitely, sawbones.com or perryinitiative.org.
Yeah, it's really great that all those lessons are pretty much hands-on, is what it looks like.
Yeah, every one of them. And they all start with the story of basically somebody who got injured. So it's a story of an orthopedics injury. So we have, a rock climber whose hand is cramping. So you learn how the hand works and how that's very similar to cable pulley systems. Or a mountain biker who has a bad accident and they break their tibia. So you learn how fracture repair works and what are some of the engineering concepts that go behind that.
So Jenni was joking about it revolving around injury, but really, so that was a non-negotiable for both of us in the development of this curriculum, was that we wanted the curriculum to be couched in some kind of relevant problem and something that was like an everyday problem, right? So one of the things that I see as an educator is that we often forget or we accidentally marginalize particular groups of students when we really focus on rockets and cars. And that leads kids to misconceptions that, like, if I don't like rockets and cars, that I can't be an engineer. And we really wanted, and we pushed the team to really think of a relevant problem that a high school or middle school kid would find interesting, right? So rock climbing and bicycling and diving off a diving board, those are everyday problems or situations that the kids can relate to.
So speaking of that, how do you know that your development team basically chose problems that the kids really are interested in? Do you follow up with any data if kids are learning or if they're becoming more interested in engineering?
Yeah, totally. So my development team was actually in my class. So they were coerced by grading to do a lot of evaluation. That's one of the things we stress here. So they were in close to a dozen classrooms during the development of OIA. And then since that time, we've collected data on various classroom settings. Some have been summer camps, some have been teachers that are using our curriculum. And we basically look at, pre-post surveys of what the kids are learning during the lesson. Some of the questions are related to, like, do you feel more comfortable with mathematical modeling or data collection after you do this? And we see some gains there. Amy and I are planning a longer term follow-up with all the folks that have adopted our curriculum, some of whom, again, we don't know. We have emails. We'll be looking at various ways that this has been implemented in both teacher and student feedback more in the long term. But definitely we saw some real short-term gains, and those classrooms that we field tested in, it was not uncommon that we had teachers say, like, this is not durable enough. You need to go back and redo this, or this isn't the way that I would explain this. And we really listened to that and incorporated it. So by the time we were ready to launch, we had a lot of feedback from teachers.
You also mentioned how you really spent a lot of time mapping the learning goals of the curriculum to the standards in different states and NGSS, that kind of thing. And I guess, Amy, you were really key to that part.
Yeah. So, the adoption of the next generation science standards is really kind of a watershed moment, I think, because it gives us the opportunity to legitimately embed engineering design into the entire K through 12 grade span, instead of just reserving it for high school, where I think it's sort of been relegated in the past. So I see it as an opportunity, and we definitely tried where we could to map the lessons to the next generation standards, so that the teachers could see that this is not about just adding something in, but rather a tool for integrating and making their curriculum more cohesive throughout the academic year.
Okay. Yeah. And speaking of which, you said, Jenni, you said that you and Amy had met because of Orthopaedics in Action. There are other people listening who might want to create their own curricula as well. How does someone find someone like Amy to help them create a curriculum that works like that?
I don't know how I found Amy. Well, I mean, being on a university campus kind of makes it super easy, right? I mean, we kind of bump into each other, but I would say if you're a teacher and you have some ideas that you need to get built out, right? So let's say you have an idea for curriculum, your local university, the engineering students there are a great resource. And sort of the other way around, if kind of like me and are looking for an Amy to help with mapping the curriculum, again, I mean, I would point towards your district curriculum specialist or your local university.
Yeah.
Okay.
I would say too, Pius, that I think just going to your trusted colleagues and tossing ideas around and seeing what you can come up with is often just a really first good step. And then after you've done that, I think reaching out to, a trusted university partner or, some, like Jenni was saying, somebody in your districts, you got a district science or STEM specialist, reach out to them. They're often a really good source of knowledge.
We'll continue the conversation after this short plug. If you like this podcast and you want to help me keep it alive, please consider contributing a bit to my new Patreon page for my studio. It's at www.patreon.com/Pios Labs. You can also find the link in the show notes or at the podcast website, k12engineering.net. Finally, if you listen all the way to the end of this episode, I mean the very end, you can hear about my new guide that's available on Amazon and other booksellers. The guide is called Engineer's Guide to Improv and Art Games. Thanks, and now on to the show. And speaking of collaboration with education specialists, you also mentioned corporate partners, basically like Sawbones helping you out. Are there any other people that you collaborated with to get this done?
Absolutely. Yeah. I mean, the Perry Initiative, I've had a relationship with Project Lead the Way since sort of the beginning of days for the Perry Initiative. They've been sort of like called my big sister nonprofit. So Project Lead the Way is a pre-college engineering program. They actually do bioscience now and computer science as well, but they sort of started in the engineering space. We've been part of that network in the Perry Initiative for 7 years at this point. And then more recently, in my role here at University of Delaware, I've been able to advocate with Amy for us to become a Project Lead the Way affiliate university to have teacher professional development for PLTW teachers here. And that's been a really great experience. So for like Orthopaedics in Action, one of the first groups of teachers that we surveyed were Project Lead the Way teachers. And we were able to ask them, here are teachers who are teaching engineering concepts or teaching bioscience concepts. What do you think if we were to create something like this? Is this relevant? What would you use it for? And that was really great feedback. And then, in turn, like we've been able to kind of expand and distribute the Orthopaedics in Action curriculum through that network. So they've been a great partner. And then also, University of Delaware has been very supportive of this collaboration between our two colleges, College of Engineering and College of Education and Human Development. And it's just led to more stuff, like our two colleges. I teach a course on, it's our sophomore design course. It's basically where we teach our students how to use computer programs like SolidWorks or Autodesk to create objects on the computer and then manufacture them. And we partnered with our College of Education and Human Development students to create toys for kids. So that was really an exciting thing that I don't think we would have taken on or done as well were we to act in isolation. So it's really led to some great partnerships between the two groups.
There are several things I wanted to ask you about there. One was, can your Project Lead the Way teachers integrate the Orthopaedics in Action lessons pretty easily?
We have had quite a few Project Lead the Way teachers who've taken up Orthopaedics in Action. And from what we've heard so far from them, feedback from them has been that it's been fairly easy to do. The reason being that each of our lessons, each of the OIA lessons could be run really in any order. What we've heard is that OIA has been a really good experience for them, showing students in their bioscience classrooms that engineering is relevant to the biosciences, particularly maybe females, because what happens is a lot of times you have a high concentration of females in your bioscience classrooms and then a high concentration of males in your engineering classrooms, and you'd like to try to balance that out. So this curriculum can be helpful for that, because you can show the women in biosciences that there's engineering content and maybe get them excited about taking an engineering class, and sort of vice versa for your male students. So it's been a really good partnership with them, and we look forward to kind of branching out even more within the PLTW network.
Do you think that there are particular types of people or students that do especially well or are especially interested in orthopedics and this type of engineering?
It's kind of all over the map. I think I've seen students who are very much in their heads, right? Very theory driven. And then when you expose them to this type of hands-on work, this is very hands-on work. They really blossom. Obviously students that are already drawn to kind of working with their hands are, it just reinforces that for them. So I would say it's all over the map. I mean, with our outreach program, we literally have girls come in there who've never held a power tool before. I mean, we give them a DeWalt drill, right? And just tell them to go for it, drill into some fake bone. And, they start off really tentative because they haven't been, these are top kids, right? These are STEM inclined females who are doing very well, junior, senior year in high school, obviously going to college, going to great places. And they haven't really thought that they had that skill. So I think it's appealing to pretty much any type of learner.
That's great to hear. And related to the college class you were talking about designing toys, is that right?
Yes, yeah.
That sounds awesome to me as well. And I think that a lot of teachers in K-12 would be interested in doing something similar. Do you think that that's possible? Could they pull something like that off?
Yeah, and I've seen a lot of great curriculum out there, and MIT has some great information online. They run a toy design class, and it's part of their open course materials, so you can kind of see what they're doing. But I mean, I took a class that was sort of designing really boring engineering objects like engine mounting blocks and this kind of stuff, and and redid it as, hey, how about we build toys for kids, and one step further, how about you give it to a kid and you see what their reaction is and then make improvements based on it. So we start off doing a pull toy, like a little child pulls the toy behind them, and that's a great way to teach about fits and tolerances and some of these concepts that you might be teaching in your engineering classrooms. And it's also fairly simple geometry. And it gives everybody an even playing field for starting to model on the computer and starting to build with their hands. So I actually do that as an individual project, and then I step it up from there into a group project where they can kind of create whatever they want within some bounds, so long as they have good justification for doing so. So as we continue, I think we're going to put more and more out there about the course that we're designing, but there's definitely some other great resources.
Okay. I could also imagine in a course like that, they could integrate a lot of different fields as well, like electronics or coding, as well as the mechanical design. Yeah,
and there's stuff like, one thing that we wind up doing in that toy class is we use the toy safety standards a lot. I know that sounds super boring, but that's kind of fun to show. As an engineering educator at the college level, I need my engineers to understand that there are standards behind any commercial product that's designed, especially for safety. But it's kind of a fun way to also bring in a little bit of physics. So I don't know, did you know that every toy needs to be dropped from about 4 feet onto linoleum and still not break apart?
I did not know that.
Yeah. Or there's like a great shake test where you was this going to stand up to FedEx shipping? Let's put it in a box and shake it around.
I could just imagine your students shaking a toy doll or something over and over.
They totally do. Yeah. Or, the choke test, if you see a toy that's approved for under 3 years old, it none of the parts on that toy can fit down a child's esophagus, and there's actually a measurement for a child's esophagus. So you can tie in a lot of other stuff by looking at the engineering literature, and that makes for a great learning exercise too. Does your toy meet the safety standard?
Actually, maybe more towards Amy, but I was wondering, in your experience with all of this, and you too, Jenni, what items are basically the biggest challenges that you think teachers face when they have to teach an engineering course? Because we found that teachers who teach engineering, they don't necessarily always have the engineering background.
Yeah. the biggest challenges, I think any teacher will tell you, like if you surveyed 1,000 teachers and you had to distill their responses down, the two things that are limiting in most educational settings are time and resources, right? So I think one of the biggest misconceptions I hear from teachers is that engineering has to be like, you have to have these like really sophisticated tools in order to teach engineering. And I think that's one of the great things about meeting Jenni, is that she's shown me that engineering can happen with everyday objects, right? Like it doesn't have to be, you don't have to have an entire carpentry shop or machine shop to do engineering with kids. You can do pretty sophisticated engineering with everyday objects. And I think an example of that, right, is Engineering is Elementary's curriculum that comes out of the Boston Museum of Science. Their curriculum is genius in that way, right? Like they have these incredible lessons set up for kids to engage in different fields of engineering, just using things like popsicle sticks, glue, rubber bands.
And it's not like bottle rockets and,
it's
mousetrap cars, right? Like we have enough of that. Like this is not things that go vroom.
No, it's not bottle rockets or cars. It's definitely like can you solve a problem related to water quality, right? Like, so I think teachers having a set of resources that they can use initially to try out and then refine based upon what they're observing in their classroom is super helpful. And there's all kinds of resources, I think, now on the web for curriculum for teaching engineering and integrating engineering into regular class time, like STEM or science classrooms, or even an enrichment period if you have that at the beginning or end of the day. And I the other thing too is the time factor. And the thing I want to come back to is I always challenge teachers, don't look at engineering as an add-on, look at it as a way to enrich what you're already doing in the classroom, right? And refine it so that the engineering process becomes, part of what the kids are already doing in the classroom. Just like we engage kids in science investigations, engineering design is the same, right? It's a way to sort of manifest students' understanding about science and about math in order to build something to achieve some purpose or to solve a problem. And I think really that's what engineering is all about.
Yeah, you mentioned a lot of great resources to help overcome these challenges. And that actually was leading into my next question. I was wondering if you could suggest to any other resources that teachers might find really helpful, maybe easy to use resources.
So there's some great websites like teachengineering.org is one.
NAE, there's an organization called Change the Equation, changetheequation.org, which has a lot of great resources. NAE is the National Academy of Engineering is another one that they put out their grand challenges of engineering. So if you're sort of looking for what are some real world problems that engineers are trying to solve, you could look there. Amy already mentioned Engineering is Elementary is really great curriculum at the elementary level that is very accessible and very low barrier to entry. If you're sort of looking for, very well done, kind of fully packaged type curriculum, Project Lead the Way is excellent. And both of us feel like every level that they're operating at, they're doing a pretty good job. And then I've been impressed by the more and more I read in the educator literature and sort of the trade magazines, the more I see some really, really exciting curriculum coming out.
Yeah. The National Science Teachers Association, all of their journals, and then they publish great resources, their books. There's a lot of STEM, integrated STEM and engineering publications they've been putting out in book form that you can either purchase the book, have the electronic form of the book, or get a physical hard copy. So NSTA is another great website. It's a great organization. They're really committed to helping teachers make sense of the next generation science standards and integrate those standards into the classroom.
That's great. Yeah, the NSTA also has a podcast that I like to listen to, Lab Out Loud. I don't know if you're familiar, but they're really neat. It's like two science teachers who talk a lot about different resources that they find as well.
Great. Yeah, and then when I look for ideas for projects, to be honest, I mean, I'm also looking at like, I don't know, one of my favorite books of all time, this is maybe how I knew as an engineer, was The Way Things Work by David McCullough. Like, you could just you can just have kids learn a lot about how things are put together by doing a machine dissection, take apart a sewing machine and have that book right next to it. I mean, it's incredible. So there's a lot of just kind of books out there that are also a great way for kids to explore mechanical objects and engineering systems. Yeah.
Great. And what about if teachers want to find out more about all of you and everything that you're doing, in addition to Orthopaedics in Action? Where can they look?
Yeah, just look us up. University of Delaware. Delaware is a state. On the very, very small state.
Yeah, I gotta admit, people in Texas don't always talk about Delaware, so I will promote it over here.
Yeah. So you can find us online through University of Delaware's website, and we'd be happy to talk. We're both pretty accessible.
So I have a Twitter handle. My Twitter handle is at Amy _Nare NARE, and Perry Initiative also has a Twitter feed.
We're on Twitter. We're tweeting. Yeah.
Awesome. I'll make sure to add all that info into the show notes today so people can look all that stuff up. I think that was really the last bit of questions. I know that I'm over time here, but is there anything else you'd like to add? Any other tips for teachers or engineers or parents listening?
I don't know.
Yeah, it's fun. It's not just for, the 10% of the geeky population. Like we need all the talent and all the diverse minds that we can get in this field. So if you've got kids in your classroom that aren't into what you think traditionally of engineering, I would encourage you to kind of like expand your mind. There's more to engineering than rocket ships and robots. If you like that, that's great, but there's a lot more to it as well.
Yeah.
The many resources mentioned today are linked in the show notes and at the podcast website, k12engineering.net. Please share the show with your colleagues and friends who want to promote love of engineering to all ages. Don't forget to subscribe on iTunes and SoundCloud, and to follow the show on Facebook and Twitter. Thanks for listening. Our closing music is from Late for School by Bleeptor under a Creative Commons Attribution 4.0 license. The K-12 Engineering Education Podcast is a production of Pios Labs, and you can support Pios Labs at patreon.com/Pios Labs. And now it's time for all you lucky people who listened all the way to the end of this episode to hear some cool updates for my studio, Pios Labs. And this should be a regular thing at the end of most of these podcast episodes, so we'll see how this goes. And by the way, Pios Labs is just me, myself, Pius. But I do like how my fancy business name is spelled different and sounds official. All that said, I just wanted to tell you about a new guide that I wrote, or a new book, basically, and it's called Engineer's Guide to Improv and Art Games. I wrote it because I used to do workshops with my colleague Rachel, who's been on this podcast a lot. And one workshop that always got a great reception was called Improv in the Engineering Classroom. I did it based on my own experience learning how to play and perform some improv, while also designing robots and coding. Rachel and I did this workshop with hundreds of STEM teachers, and because it was always really fun, and because people seemed to get a lot out of it, I wanted to do more. Since I can't travel everywhere doing workshops these days, instead, I wrote up this guide that explains how to play a bunch of different improv games, and also how these games can help you exercise different engineering skills. So it's a written down, amped up version of those workshops, and it targets any professional engineers or designers or engineering educators. I'm basically using the ideas in this guide to do our workshop later on at this upcoming South by Southwest Interactive Conference in March. So if this interests you, or if you can't go to South by Southwest and you want to know what this is all about, my guide is available for purchase in print at Amazon.com or as an ebook in a couple of different formats besides Amazon, and including Amazon if you've got a Kindle. So all you have to do is go to those websites and search for the title, Engineer's Guide to Improv and Art Games, or try to search for my name. And if you're a listener to this podcast, you can also get the ebook for 20% off at smashwords.com using the promo code EH22M. You heard it here only on this podcast. That code again is EH22M. That code should be up until at least the summertime of 2017. So just go to smashwords.com and you can tell me that you're a listener by using that code and getting that ebook. I'll also have this info hopefully up on my studio's website pretty soon. That's www.pioslabs.com. And that's pretty much it. Thanks for listening, and please check out The Engineer's Guide to Improv and Art Games.